Hello everyone, welcome back to lesson number 26. This is our BC Calculus, and we're talking about Taylor-Maclaurin Series Part 2. In the very first lesson that we talked about Taylor-Maclaurin Series, we talked about how to convert sine, cosine, 1 over 1 minus x, and 1 over 1 plus x into polynomial expressions. So right here at the very beginning of our notes is just a quick summary of what those are actually equal to. So sine of x is equal to what you see, x plus x cubed over 3 factorial plus 5x to the fifth over 5 factorial, etc., etc. Remember that sine is an odd function, and so that's a easy way to remember that sine has all odd exponents. Cosine is an even function, so it has all even exponents, and then our very awesome 1 over 1 minus x is just very simply 1 plus x squared plus x cubed. 1 over 1 plus x, we just flip the signs of the polynomials where we have an odd degree. So this would be a negative, this would be a negative, and this is a negative. Integral of convergence, which is over here, we are going to talk about that much later into the course. So this is not something we need to worry about right at this moment in time. But we will get into the interval of convergence towards the end of the period. So for this particular video, we're going to talk about how to find the Taylor and Maclaurin series for x transcendentals. So we're going to start with two pretty straightforward ones. Maclaurin series for e to the x, and then we're going to do the Taylor series for 1 over x, and it's going to be centered at x equals 1. I wanted to show you guys an example of, well, the Maclaurin series for e to the x is one that you should memorize like you see up here. But then let's just refresh our memory on how to find a Taylor series of just one random function. So that's the goal of the video today, and then we'll come back in the next video and talk about some more examples of what to do. Okay, so we're going to go ahead and find Maclaurin Taylor series for y equals e to the x. Remember that Maclaurin series is a Taylor series. It's just that it's centered around c equals 0. And so what we're going to do is remind ourselves of the equations right here. All right, so it's kind of helpful for us to do this. And so in this particular example, c is going to be equal to 0. So all those are going to go away. And so what we really just need to do is remember find what f of 0 is, f prime of 0, f double prime of 0, and then f treble prime of 0. And that's what we're going to do. We're just going to find a degree of 3, right? So we're going to find a degree of 3 of this series right here. All right, so let's do it. So the first one is, let's find what f of 0 is. Well, f of 0 is just going to be e to the 0, which is going to be equal to 1. So our first term here is going to end up being 1. Okay? So let's go ahead and just write this for e to the x is just going to be equal to 1. And then let's find the derivative of this. Well, the derivative of e to the x is e to the x. And if I go ahead and plug in 0, sorry, I'm going to get 1 again. So my first term is going to be plus 1x. And then the next part about this is, let's find the second derivative. So f double prime of x. Well, you guys are going to see clearly a pattern here that no matter what derivative I find, my derivative is going to always be e to the x, right? There's no e to the 2x or 3x where I have to worry about constants. It's just e to the x. So this is going to end up being 1. So then my next problem is going to be plus 1 x squared over 2 factorial. And then the last one, and you guys can see this, like I said, this pattern here. So if I find the third derivative, it's e to the x. And so the third derivative at x equals 0 is 1. So there should be no shock here that this is going to be x cubed all over 3 factorial. So e to the x, the polynomial for e to the x is very similar to 1 over 1 minus x. The only difference is that you have a over 2 factorial over 3 factorial. So these are pretty similar to each other. Okay, pretty similar to each other. So if I want the nth term of this, all right, so let's say we want the nth term of this, so this would be plus dot, 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 then this is just going to be x to the n all over n factorial. Okay? And that's it. That's all you have to do here. So we now know technically five Maclaurin polynomials. I want to stress again, and I should have said that actually earlier up here, these are Maclaurin polynomials for sine, cosine, and 1 over 1 minus x, right? This is where our c is actually equal to 0. So this is our next one. And, you know, it's a good thing about this, ladies and gentlemen, is that if you don't memorize them, you could take a quick second and actually solve this on your own, right? So these are not that challenging to do. So let's go ahead down here and do our next example, find the Taylor polynomial for y equals 1 over x centered at 1. So first thing I'm going to do here before we do this problem is we're going to rewrite this as y equals x to the negative 1. It's just easier for us to find derivatives and multiple derivatives for us to do it that way. Okay, so let's go ahead and plug in f of 1. Because remember, we're looking now at, again, the equation that we have right here. But now our c value is 1. So we can't plug in 0, we're going to plug in 1 to every derivative that we have. And then we're going to remember that we have to do the x minus 1 for each of our terms as well. So that's the only difference, really, for this problem. So, well, this is easy. Let's just plug in 1 here to our function. So we're going to get 1 is equal to 1. So px of n, or well, pn of x is just going to be equal to 1. Right? This is technically x to the 0 derivative over 0 factorial. So we really do have a power of 0 over 0 factorial. But again, x to the 0 is 1, 0 factorial is 1, so it ends up just being 1. So it actually ends up being pretty sweet like that. All right, let's find our first derivative. And I'm not going to do too much with this. I'm going to pull the negative 1 down. And then I'm going to subtract 1 from the exponent. And so I'm going to just go negative 1 over x squared. And again, you guys will see a pattern here when we do these problems. So this one is going to be equal to, let's plug in 1, right? So we can go ahead and plug in f of 1, f prime of 1. And we're going to get negative 1 over 1, which is going to be negative 1. So this is going to be minus 1. And then remember, because this is a Taylor polynomial, it's going to be c minus 1. Technically to the first power, and let's go ahead and do it, all over 1 factorial. Okay, because this is our first degree. So everything's a degree of 1, 1, and then this ends up being 1. Okay? Now we're going to find the second derivative. And I am going to look back at this. I think this is so much easier to do it that way. So let's go ahead and move the page down a little bit so we can get some room here. So negative 2 times negative 1 is going to be positive 2, x to the 1 less power. And we're going to get 2 over x cubed. Okay, 2 over x cubed. And I'm going to go ahead and plug in 1 to my second derivative. And I'm going to get 2 over 1, which is going to be equal to 2. So my next term is 2. So it's going to be plus 2. And then I'm going to do c minus, or x minus, oh shoot. I just realized, guys, that this actually should be 1. So now some of you guys are probably like wondering, like, why did he put a 1 there? So it should be 1. So I eventually got to it. So 2 factorial over 2. Sorry, raised to the second all over 2 factorial. And let's go and do another one. So let's find our third derivative. And so again, I'm going to look right here at this. I think this is easier. So it's going to be negative 6, x to the negative 4. And so our derivative is going to be negative 6 over x to the 4th, which again, if we plug in 1 to our function, we're going to get negative 6 over 1, which is going to give us negative 6. So here, it's going to be negative 6, x minus 1 cubed over 3 factorial. Okay? Now, this is where we can start looking at patterns and see what's going on. Well, the first thing I want you guys to notice here is that 1 factorial is 1. So these essentially go away. 2 factorial is 2 times 1, which is 2. Well, that's going to cancel with this. 3 factorial is 3 times 2 times 1, which is 6. So these are going to cancel. If we were to do one more term, right, we would have done one more term, we would have gotten 24, positive 24, x to the negative 5. And so if we would have plugged in, we would get a plus 24. So our next term would have actually been plus 24, x minus 1 to the 4th over 4 factorial. And you would notice that, again, 4 factorial is actually 24. So what's going on here? Well, our actual series is going to be p n x. I'm going to run out of room, of course I am. 1 minus x minus 1 plus x minus 1 quantity squared minus x minus 1 cubed plus x minus 1 to the 4th. Da, 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 da. And so you guys can see here that every time I have an odd exponent, it's going to be negative, and every time I have an even exponent, it's going to be positive. And so, again, usually it would tell you here, let's just go to a degree of 4. Okay, so a degree of 4, which means our highest degree is 4. And I know we talked about this in the previous video on Maclaurin and Taylor series, that this would be the 5th term. First term, second, third, fourth, fifth. All right, so remember there's a difference between terms and degrees. And that's it. That's all we have to do for these problems. All right, so we're going to come back and we'll do more examples for you, but that's going to be good enough for the first video on more Maclaurin and Taylor series. So I'll see you guys in the next video.